Hi, good day to you all. Welcome to another chemistry class. So today we'll be talking about pH. Yes, pH. The full meaning of pH simply means the potency of hydrogen. Now, we already know that an acid produces hydrogen ion as its only positive ion. A base produces hydrazine ion as its only negative ion. Acid, hydrogen ion, positive. A base, hydrazine ion, negative. Now, when the substances produce this positive and negative ion, what actually happens? When they produce it when they combine, that is what they produce. When they dissolve in water, that is what they produce. So now, enabling us to understand more about the pH. The pH of any substance is graduated like this. For you to get the pH of a particular substance, you need to know what a pH scale looks like. A pH scale ranges from 0 to 14, making 7 the neutral. 7 here is the neutral. Any solution or compound that has a pH of 7 is a neutral solution. While from 7 down to 0 are acidic. From 8 down to 14 are basic or alkaline. Now, increasing acidity is from 6, 5, 4, 3, 2, 1. Meaning, if a solution has a pH of 1 and we have another solution with a pH of 5, it simply means the solution with a pH of 1 is more acidic than the one with a pH of 5. So there is increase in acidity from your right hand side, which is the neutral, to your left hand side. Alkalinity, yes. Here we have increased alkalinity. That is, if a solution has a pH of 10, it is higher in alkaline than the one with pH of 8. So from 8 here down to 14 is increase in alkalinity. Now, for us to calculate our pH, we need to know that our pH plus pOH must be equal to 14. Yes, that is the sum of the pH and the pOH must give us 14. And also, hydrogen ion concentration and the hydrazine ion concentration, wherever you see that bracket, this type of bracket, it simply means concentration. So the concentration of hydrogen ion as well as the hydrazine ion must be equal to 1 times 10 raised to the power minus 14. That is the concentration of the product of this and this. That is the concentration of this and that of this must give us this. Also, if you want to find the pH of any solution with hydrogen ion concentration, then you use minus log of hydrogen ion concentration. Likewise, the last one, for you to get the hydrogen ion concentration, given the pH, then you use this last formula. Now let's get down to business in order not to waste our time. Let's start with the first one. Find the hydrogen ion and the hydrazine ion concentration in this solution as well as this solution. Now the first solution is H2SO4. Now let's start. H2SO4 produces what? It's going to produce 2H plus and SO4 2 minus. So we don't need this SO4 2 minus. We are concerned with this H plus. So if the concentration, let's take the first solution, A. We have 0.02 molar here. Because it's an acid, so our hydrogen ion concentration will be what? 0.02 times 2, because we have 2 molecules. That will be 0.04 mole per dm³. Do you get that? That's the concentration of the hydrogen. Now we're told to look for the hydrazine ion concentration. Look at this formula. The H plus and OH must give us this. So for us to find the OH, we must say this over that of this. So let's go. For us to find the hydrazine ion concentration, we'll now say 1 times 10 raised to the power minus 14 over 0.04. Using indices, we just say 10 raised to the power minus 14 over 4 times 10 raised to the power minus 2. 1 over 4 will give us 0.25 times, because you are dividing, so you have to do what to the power, you subtract. Minus 14 minus minus 2 will give us 10 raised to the power minus 12. Are you there? So, what do we have here? That will be 2.5 times 10 raised to the power minus 13 mole per dm cube. That is for the hydrazine ion concentration. We already know that of the hydrogen, and this is the hydrazine. Now look at the B part. The solution is basic, where we have 0.005 molar of sodium hydroxide. So here, we are concerned with the hydrazine ion. So our hydrazine ion here is 0.005. So what will be our hydrogen ion concentration? So we'll say 1 times 10 raised to the power minus 14 over 0.005. You can as well write this as 10 raised to the power minus 14 over 5 times 10 raised to the power minus 3. 1 divided by 5 will give us 0.2. Take this one up, we have 10 raised to the power minus 11. So here I'll be having 2 times 10 raised to the power minus 12 mole per dm cube for our hydrogen ion concentration. For our hydrogen ion concentration. So we have 2 times 10 raised to the power minus 12. Now let's take a look at the second example. Find the pH of a solution. This is the hydrogen ion concentration. So invariably, this one is straightforward. We just make use of pH equals this, because we are looking for pH. pH equals minus log of hydrogen ion concentration. What is our hydrogen ion concentration? We are given as 0.001. So that will be 0.001. So now let's press our calculators to find the pH. We go to the minus, then log, you press a log, 0.001. And that will give us 3. So, pH equals 3. Did you get that? Simple as ABC. Now let's take a look at the last question. I hope you can still see the board. Okay. Now, we were given the solution of pH 5.3, and we are told to find the hydrogen ion concentration. We look at the suitable formula to use. We don't have anything to do with hydrazine, so number 1 and 2, pew. We were given the pH, but do we know the hydrogen ion concentration? No. So we'll go to the last formula. That is finding the hydrogen ion concentration. You just say the antilog of the minus pH. So what is the pH given to us? 5.3. So we have the antilog of minus 5.3. You all know how to press antilog on your calculator. That is the shift key, the shift button, log, and minus. Remember to put that minus. 5.3. So we eventually got our hydrogen ion concentration as 5 times 10 raised to the power minus 6 mole, because it's a concentration, mole per dm cube. Is that taken? We have different formulas. You have to study the formulas well for you to know which one to apply based on the type of question asked. Okay, we'll continue in next class. Take care. Bye.